everybody. Welcome to Monday, April 26th. I'm out of the classroom today, so thank you for following along with this video today. Make sure you give our guest teacher much respect. All right, so today we are going to be taking a quick quiz, but we're going to be doing some review before we get started, and I have an Estimistry lined up for you. So while I get this loaded, I need you to get your math notebook out. I need you to get a pencil out so that we can be challenged with this prism challenge. Sounds interesting. Looks like we're looking at some pattern blocks today. All right, so remember, in an Estimistry, you're given clues and you need to narrow down your estimate each time a clue is given. So let's get started. How many prisms are there in the vase? Well, when you look closely, I see hexagonal prisms and I see trapeziums, which is a trapezoid prism, right? So there seems to be two different shapes. So keep that in mind. It looks like our vase is a little bit broader on the bottom and the top, kind of like an hourglass shape. So go ahead, I'm going to give you about 30 seconds. Write down your best estimate for how many prisms are in the vase. All right, so remember, as the clues appear, use the information to narrow the possibilities to a smaller set. So that just means change your estimate. After each clue, use estimation again to determine which of the remaining answers is the most reasonable. So at this point, you should have your first estimate written down. I would like you to draw a big circle around that estimate. And then after each clue, we're going to take a look and see, is your estimate still a possibility, okay? If your estimate is not a possibility, we're going to write down a new estimate and move on. Here is clue number 1. The answer is an even number. So what does that mean? An even number. I'm hoping that you're thinking that it needs to end in 2, 4, 6, 8, or 0. So please take a moment right now. Look at your number. Does it end in 2, 4, 6, 8, or 0? My number does end in a 2, 4, 6, 8, or 0. If your number does not, I need you to choose a new estimation. All right, clue number 2. The answer is not a multiple of the number of vertices found on a trapezoidal prism. All right, so we talked about how we have trapezoidal prisms in our picture. They are red. And can you remember what vertices are? Vertices are like the corners, right? So if we look at a trapezoidal prism, I can see this one way up at the top here. Okay, I know there's 1, 2, 3, 4 vertices on this side, which means there needs to be 4 vertices on the other side, 8 in all. 1, 2, 3, 4, 5, 6, 7, 8. So it says the answer is not a multiple of the number of vertices found on a trapezoidal prism. So in my notebook, I'm going to write down the number 8. Oh, guess what? That takes my number out. I had 64. So if we count by 8s, 8 is out. 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96. Not sure if there's more than 96, but if you have any of those numbers, you're out, right? Clue number 3, the answer is not a multiple of the number of faces found on a trapezoidal prism. Faces. Do you remember what a face is? Faces on shapes are a lot different than faces on a human. There are some similarities though, but the faces are going to be the flat parts. So again, if we look at our trapezoidal prism right here, we have our trapezoids and there are 2. So 1, 2. Then we have the bottom face, which would be 3, 4, 5, and 6. There are 6 trapezoidal faces, or not trapezoidal faces, but just faces on a trapezoidal prism. So the answer is not a multiple of the number of faces. So in addition to the numbers 8, 16, we should be writing these down right now if you don't have a hundreds chart in front of you. So it cannot be 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, or 96, because we know those are multiples of 8. And now it also can't be any multiples of 6. So let's count by sixes together. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72, 78, 84, 90, 96. How about we stop there? So if you had any of those numbers, can't be it. My second guess is still alive. Remember, it has to be even. So your number has to end in 2, 4, 6, 8, or 0. All right, clue number 4. The answer is not one more than a square number. Man, they are just really challenging us with this estimatry today, right? So what does it mean, a square number? Well, when we look at like the number 2, okay? What is 2 times 2? Well, 2 times 2 is 4. That is a square number because we're multiplying 2 by itself, right? So 2 times 2 is 4, which means our answer cannot be 5. We already know it can't be 5 though, right? Because 5 is an odd number. So let's look at 3. 3 times 3. So 3 squared is 9. What's one more than 9? 10, right? So it can't be 10. Hoping you didn't have 10 as an estimate though, because that's pretty small. All right, next square, 4 squared. 4 times 4 is 16. Add 1 to that is 17. We already know it can't be 17 because 17 is an odd number. All right, let's go to 5. 5 squared is 25. 25 plus 1 is 26. If you have 26, you need to find a new estimate. Is anyone noticing a pattern here? Because I definitely am. 6 squared. 6 times 6 is 36. Plus 1 is an odd number, 37. So we can't even use that anyways. What is 7 squared? 7 times 7. Do you notice that it's going odd, even, odd, even, odd, even? So when you square an even number, you get an even number. And then when you add 1, you know it's going to be odd. So you know what? I don't even know if I need to look at any of the other even numbers, quite honestly. But let's just see if our pattern holds up. So 49 plus 1 is 50. If you have 50, you need a new guess. 8 times 8, I know this isn't going to work out anyways, but just for mathematical proof, 8 squared is 64, and 64 plus 1 is 65. We know that isn't a choice because it has to be even. 9 times 9 is 81. Plus 1 is 82. That would work. And then 100 times 1, or 10 times 10 is 100, plus 1 is 101. We know that doesn't work, so we'll stop there. So if you had 10, 26, 50, 82, you need to find a new answer. All right, hopefully clue number 5 is our bombshell here. The answer does not include the digits 4, 6, or 8. Oh man, I just lost my second estimate. Did you? Okay, so it takes out all the 40s. Okay, it also takes out 54, 56, 58. So in the 50s, we only have 50 and 52 available. So if you have 50 or 52, actually 50 is out. 52 is alive. All right. It takes all the 60s out. So that was me. So now I'm going to have to go to a 70. So if we look at 70s, 72 is out. 74 is out. 76 is out. 78 is out. But 70 is not out. So if you have 70, you're still alive. Okay, all of the 80s are out, all of them. If we look at 90s, 90 is out. Let me see my thing. Looks like 92 is still alive. But 94, 96, 98, those are all out. Wow. So really, it looks like we're down to 52, 70, 92. Do you have one of those? I don't know. I don't even know if I've been keeping track correctly, but that's what I seem to have on my paper as far as what's still alive. All right, so let's take a look. Square your best shot. I've got mine squared. All right, our answer is 70. That was my last guess. 70. So I did it in 3. How many did you do it in? That was a lot of work, though. They really tested us on this one with all of their big vocabulary, but hopefully you were able to follow along and had either 52, 70, or 92 at the end. I had 70. My original guess was 64. And then I changed it to 62 and then finally 70. All right. Hope you had fun with that. Let's move on to the rest of our lesson. So today we are going to gear up for quick quiz number 2, and we are going to do a little bit of reviewing from last week. All right, so last week we talked about generalizations. So we're noticing patterns related to the size of the product when multiplying whole and fraction numbers. All right, success criteria. Well, we left off on this on Wednesday, right? So I can predict the product will be greater when a factor that I'm multiplying by is greater than 1. So they're talking about greater than the original factor or one of the factors. I can predict that the product will be equivalent to a factor if the other factor you're multiplying by is equal to 1. And I can predict that the product will be less than the other factor when a factor is less than 1. All right, so what is a generalization? Remember, a generalization is a statement about a group that is true for most of the group, okay? So if we think about these peppers, the peppers are hot. They are peppers, so they must be hot. And then we talked about mathematical generalizations, right? When we counted by 10, there was a 0 in the ones place when we started with 10. If we started with 12, the generalization was that there's always going to be a 2 in the ones place. So the overall generalization is the ones place stays the same. When we counted by 5s, we said, hey, the ones place alternates. When you start at 5, it goes 5, 0, 5, 0, 5, 0. But when we started by 2 and added 5, it went 2, 7, 2, 7, 2, 7 in the ones place. So these are generalizations that work most of the time, if not all of the time. All right, for today, you will need your math notebook. Your math workbook. You are already on your Chromebook. You'll need your notebook, pencil, Climb sheet are available. Just ask the guest teacher. Otherwise, they're always located on this slide. So let's review generalizations that we learned on Wednesday. So the first generalization that we talked about is that when we multiply by a factor that is equal to 1, our product will be equal to the other factor. So we can use a model to determine how the size of a product compares to the size of one factor when multiplying. Okay, so when the factor is 1 and we're thinking of 2/3 times 1, we could draw a model to represent the factor of 1. Okay, so I have one whole shape right here. There's my 1, and I'm dividing it into 3 equal sections. And if I shade 2 of the sections, because 2/3, okay, to represent the factor 2/3. 2/3 of the rectangle is shaded, so 2/3 times 1 is what? Greater than, less than, or equal to 2/3. Okay, when we multiply by 1, our answer is going to be the same as the other factor, because 1 times any number is that number. All right, when we multiply by a factor greater than 1, our product will be greater than our other factor. So the factor is greater than 1. We are multiplying 2/3 by 2. So I am going to start by looking at 2 rectangles. Here are my 2 wholes. And because I'm multiplying by 2/3, I am going to split them each in 2/3 and take 2/3 of each whole. 2/3 times 2 is going to be 4/3. I have 1, 2, 3, 4. 4/3 is greater than 2/3. Okay, when I multiply by a number that is greater than 1, my answer will be greater than my other factor. I had 2/3. I multiplied by 2, which is greater than 1, so I'm getting an answer that is greater than 2/3. 4/3 is greater than 2/3. And then finally, when we multiply by a factor that is less than 1, our product will be less than the other factor. So for this situation, I am starting with 2/3 and I'm multiplying it by 1/6. I know that 1/6 is less than 1 whole. So I can start with 1 whole. And here is my 2/3, if I wanted to take my 2/3, right? Here's my 2/3, but I'm only going to take 1/6 of each third, okay? So I'm going to take 1/6 of each third, which is going to leave me with 2/18. That is a lot less than, if I colored in my whole section here, remember we talked about crisscrossing? I should have crisscrossed for you. And here's 1/6 of 2/3. So there's my 2/18, okay? So 2/3 times 1/6 is less. All right. Remember to compare the number to 1 whole. Some of you were comparing the factors to each other. That is not what we're doing. You were like, oh, 3/5 is greater than 4/7. Nope, that's not what we're doing. We're comparing the factors to 1. Is it greater than, less than, or equal to 1 whole? So in number 1, it says 3/5 times 4/7 will be, pretend we didn't know this, right? Greater than, less than, or equal to 4/7. So I'm looking at 4/7. What am I multiplying by? I'm multiplying by 3/5. About 3/5, we say, is 3/5 greater than 1, less than 1, equal to 1? Well, I know that 3/5 is less than 1, therefore my product will be less than 4/7. So let's try this. On number 2, this isn't in your workbook, so let's put this in your notebook that you should have out and handy. It says 5 times 7/8 will be greater than 7/8, less than 7/8, equal to 7/8. So let's go ahead and circle up 7/8. Take a look at what we're multiplying by. I'm multiplying by 5. Okay, so you're not comparing 5 to 7/8, you're comparing 5 to 1 whole. Is 5 greater than 1, less than 1, or equal to 1? Well, I'm hoping that in 5th grade we know that 5 is greater than 1 whole. So therefore my prediction and my generalization is that 7/8 will be greater. My answer will be greater than 7/8 because I'm multiplying by a number greater than 1. All right, I would like you to try these 4 with your elbow partner, okay? So you have your notebook. I would like you to turn and talk with your elbow partner and complete the statements. There should be equal to, greater than, or less than in each blank. So please pause the video, find your partner, compare these statements using greater than, less than, or equal to. All right, let's take a look. 3/7 times 2/5. Will that be greater than, less than, or equal to 3/7? So I'm looking at 3/7. What am I multiplying by? 2/5. 2/5 is less than 1. So that means that my answer will be less than 3/7. Looking at number 2, 7/8 times 3. Will it be greater than, less than, or equal to 7/8? I'm going to circle up 7/8. Take a look at what I'm multiplying by. I'm multiplying by 3. I know that 3 is greater than 1 whole. So therefore, my answer will be greater than 7/8. On to number 3. 1/6 times 5/5. Is that going to be greater than, less than, or equal to 1/6? So let's circle up 1/6. Take a look at what we are multiplying by. 5/5. 5/5, I think it was Anna on Wednesday that told us, boom, make that into a 1. Okay? So 1/6 times 1, well, that's obviously just going to be equal to 1/6. And finally, our last one, 5 times 6/7 will be greater than, less than, or equal to 5. We're comparing to 5. We look at what we're multiplying by, 6/7. I know that 6/7 is less than 1, so therefore my answer will be less than 5. Okay, so we're using those comparisons. You're comparing the number you're multiplying by to 1 whole to figure out if your product will be greater than, less than, or equal to. Okay, now let's take a look at this problem. We have Starla. Starla is making hot cocoa. She plans to multiply the recipe by 4 to make enough hot cocoa for the whole class. If the recipe calls for 1/2 teaspoon of vanilla extract, will she need more than 1/2 teaspoon or less than 1/2 teaspoon of vanilla extract to make all the hot cocoa? Now, if we take a look at our bookmarks on problem solving that we looked at last week, first of all, to really understand a story problem, we need to read it more than one time. So let's go ahead and look that over again. I would like you to read it to yourself, and I'd like you to start circling and underlining some words, phrases, numbers that are going to help you. So please go ahead and pause the video right now. All right, so I'm hoping that you obviously underlined what we're trying to solve. We need to know, will she need more than 1/2 teaspoon or less than 1/2 teaspoon to make all the hot cocoa? How much hot cocoa is she making? How much hot cocoa is she making? Well, I see up here that she's multiplying the recipe by 4. She's making 4 times the amount, and that if the original recipe calls for 1/2 teaspoon, she needs to make 4 times the original amount. So I can set this up when I'm taking a look at my plan. If I need 4 times the original amount and the original amount is 1/2, well, I know I'm going to need more than 1/2. So in my head, I need to be able to set this up so I'm going to get an answer that is more than 1/2. Well, I know that if I take 1/2 and I multiply it by the 4 times 4 groups that she's making of this recipe of hot cocoa, then I should be getting an answer that's greater than 1/2 because I'm multiplying 1/2 by a factor that's greater than 1. So now I'm going to go ahead and solve this. So in our notebooks, let's get this set up. We know that when we have a whole number, we put a 1 under it. Now these problems are these numbers are small. If you want to cross simplify, go ahead. If you want to multiply first, then simplify, go for it. I think that's the route I'm going to do. I know that 1 times 4 is 4, and 2 times 1 is 2. I'm not going to leave it as 4/2 though. If I said, oh yeah, she needs 4/2 teaspoons, that doesn't really sound very mathematically correct, right? So 4/2 I know is equal to 2. So she needs 2 teaspoons. Teaspoons can be abbreviated as TSP. So that's not my answer though. They're not asking me how many teaspoons I need. They're asking me, will she need more or less than 1/2 teaspoon? So I know that in this case, she is going to need more, okay? Maybe you knew it was going to be more without even having to solve it. And that's awesome too, because you know that she's getting 4 times the amount because we're multiplying by a number greater than 1. Our answer would be greater than 1/2. All right. Number 8 here. Again, we should still be in our notebook. Miles is planning to spend 2/3 as many hours bicycling this week as he did last week. Is Miles going to spend more hours or fewer hours bicycling this week than last week? I want you to go ahead and reread this, pause the video, and take note of anything that you think is going to help you solve this problem. All right, I'm hoping that you were thinking that there's definitely something missing in this problem, because I certainly was when I read it, okay? Well, I know that Miles is going to spend 2/3 as many hours bicycling this week as many as. So I know that this is multiplication, and I'm hoping that you saw that too, because we talked about this a lot last week. It says that he's going to spend 2/3 as many hours bicycling this week as he did last week. Well, I put a big old question mark here. It doesn't tell me how many hours he bicycled last week, or not hours. It did say hours. I was thinking miles. So it didn't tell me how many hours he spent last week. But because we're so good at this right now, we don't need to actually know that amount. We can just call that hours, right? We can say H for hours. He spent, maybe it was 2 hours, maybe it was 5 hours. Heck, maybe he just loves bicycling so much and it was 20 hours, right? But we don't really need to know that. All we need to know is that he is biking 2/3 as many hours as he did last week. Okay? So when I am multiplying last week's hours by 2/3, is my answer going to be greater, less than, or equal to the amount of hours that I biked last week? I'm multiplying those hours by a number less than 1. So therefore, I should get an amount that is less than. And hopefully you were thinking that as you were reading. If he is doing 2/3 as many hours, that's an amount that's less than 1. So therefore, it would be less than the amount of hours that he biked last week. All right, hopefully you have your mind right, ready for your quiz. There is a lot of generalizations and comparisons on your quiz. So I would like you to hop over to Seesaw. We are going to be completing the Unit 3 Quick Quiz 2. It is also on page 109 of your student workbook. So let's all open to page 109 in your student workbook right now. I'd like you to go over these problems with you quickly. So 109, if you're not there, please get there. Please pause the video until you are ready to go. All right, because you're playing the video right now, I'm assuming that you are looking at page 109 with me. If you look at numbers 1, 2, and 3, the directions just say write the correct answer, but they're actually asking you for 2 answers. So if we look at number 1, it says predict whether the product is greater than, less than, or equal to 2/3. I need to know that on the line. I should see greater than, less than, or equal to on that line. Then it says what is the product. That is telling you to solve. So for numbers 1, 2, and 3, I should see your prediction in addition to the answer to the problem. All right, looking at number 14. 14 says, Michael and Tracy are carpeting their family room that is 15.5 feet long and 12 1/4 feet wide. To find the amount of carpet needed, Michael says to multiply 15.5 and 12 1/4. And Tracy says to multiply 12 1/4 and 15.5. Who is right? How much carpet is needed? Again, 2 parts to your answer. I want to know who is right, and I need you to solve it. How much carpet is needed? Okay? And then number 5, it's just a solve. Okay? When you are finished, you are going to tear it out of your workbook and bring it up to the pink basket in the front of the room. Please make sure your name is on it. Okay? When you are finished, you can go on to the finished early slide. If you have any missing work, we're going to work on that. You could obviously go on Freckle, and I included one of the coolest mystery pictures that I've seen so far. So whatever floats your boat, but you need to get your quiz done today during class.